So this fuel tank is off a Yamaha 1100 that I purchased secondhand. That's the bike over here. Purchased it secondhand after it was sitting in someone's garage for what was probably a number of years before he decided to sell it. The fuel tank was bone dry, not a single drop of gas. And in fact, when I removed the fuel cap, I noticed a large amount of the rust sediment. So I actually removed the rest of this here and used my nozzle wand to actually fish inside and blow it out. Now what you don't see right now is all the dust, the rusted dust that actually flew out, because I've actually done a pretty good job so far of cleaning it all. But needless to say, I had a good amount of all that sediment come out. In cleaning out this fuel tank, you also want to make sure that these here are pretty clean. So these filter silk screens you have to be very careful with, because the plastic weave on that silk screen on this filter is actually very delicate. I would only use just a very small amount of air pressure. If you use excessive air pressure on those, you might blow that silk screen right out of the plastic frame of this part. So using this tool, I actually just insert the end of the air nozzle there and just use very light pressure just to get a small amount of airflow. Nothing too drastic really. Just like that maybe. And when I initially did that, because there was that dust sediment all over caked on this silk screen, it cleared it right out into a cloud of rust around it. So it's clean now, as you can see, pretty good. But when I first did it, wow, it was dirty. Same with both sides here. So this is the silk screen for this side, that's the silk screen for this side. This is the nozzle for this side. I use the same kind of procedure to blow out the nozzles to make sure there's nothing inside the nozzle itself which could cause a clog. The nozzles you don't have to be very careful with, because it's just a rotating disc that opens up a passage depending on its position. But I usually apply the air pressure through it, just rotate that nozzle until you get airstream through one of these. Yeah, this one. Maybe this passage, the secondary passage on it as well. Yeah, this one. I'm removing the sender unit now. I wanted to see if it still reads a resistance value. So I actually connected it here with my ohm meter. I get an intermittent resistance. Sometimes it reads, sometimes it doesn't. So right there it does. So I just moved the float on the sender unit. It doesn't always read. I even tried cranking it up to the next highest setting on the multimeter here. In case it was a really high resistance that it puts out, but still nothing. And even vice versa, the lowest resistance, 200 setting, if it's a really low resistance it puts out, still nothing. So I suspect that the issue here, maybe I'll try and take this apart and see if there's a loose contact between the resistance band on the inside of the unit. Maybe I can repair the unit, and maybe not. We'll have a go at it here. So bending those little metal tangs up, this little plastic tab or cover, flipping it over, what do we find? Appears to be a wound resistive wire that's wrapped around a board. Looks like a tin coated wire wrapped around several times around that board where it's soldered to the ground or the pickup on the side. The green wire travels down this very corroded conductive lead down to that solder point on that resistive wound wire, and then eventually goes to ground. Ground is the whole chassis of this thing, which is that point right there, which is riveted to the chassis. Maybe that pivoting arm is not contacting that wound set of wire very well. This thing has a set screw on it. Maybe I can remove that whole float and remove that little tiny piece. Maybe sand it off with a very fine emery cloth or a abrasive sponge type pad, just to clean off the corrosion, which I believe is causing the high resistance or intermittent continuity on that winding of wire. I don't think the winding of wire is the issue. I think it's just that maybe it's heavily corroded around that point or not making proper contact. So after loosening off that screw quite a bit, this pivot arm won't slide through to release that. And I believe it's because the tip of that, the end of it, which is retaining it against the chassis through hole, is actually splayed or mushroomed out, preventing it from passing through. So if you were to flatten that out or file it down, it'll actually pull through and release it. Of course, then you would rely entirely on this holding it in place against the chassis, and I'm not sure the manufacturer intended for that. I'm not sure the side load characteristic that would cause this to unnecessarily take the load. If you do remove that to try and get this free, might have issues, so I actually might not remove it, just so that it stays in place where it should, because I notice I can pivot it out of the way and maybe just investigate it from the other in place without actually fully removing it. I'm thinking that's a better approach, because if you try and file that down or crush it down and then pull it through, then you reinstalling it, it won't hold back in place, and the sideways or lateral movement could cause unnecessary stress on this little tiny piece, which may cause it to lose contact again when you put it back into service. So I'm just going to try and maybe clean it up in place without actually removing it. So as you can see, I've used a 600 grit sandpaper to remove any corrosion on that little track that you see on that swing arm that I've pivoted all the way back. And on the actual winding of wire, the edge where it contacts, it's hard to see here because my camera won't quite focus. I've also used the 600 grit just to go along that edge where it actually contacts. I'll try and reinstall this and see what result I get here. So I've tightened it back up to the input shaft or the float arm. And not only have I tightened it back up, but I've actually lowered it back down a little bit so it actually sits lower. And my thinking is that it's sitting lower will actually allow that arm that pivots to press a little harder against this track pad of wound wire that forms the resistance unit. So I'm going to hook the multimeter up and see what kind of result I get here. Now that I've reconnected everything here, I'm reading about 170 ohms at the low point. And then as I rotate this through, about 900, I don't know, it's kind of at least I'm getting continuity now. A continuous continuity as it moves through. It doesn't seem to hold steady between its low and high points. It fluctuates quite a bit, but it is an improvement from what we started from. So I don't know what the low and high set points are supposed to be for the fuel gauge to read full and empty, but actually I lost contact as I pressed up on the arm. Yeah, it's not... It is better than it was before, but it's not like it was when it was new. So I get 162 ohms at the low point. About, I don't know, it's so hard to determine. Around 1,000 ohms at the high point. So here I have it connected to the output wire. So at direct continuity, my multimeter reads about 10 ohms. Sliding my multimeter probe along that trackpad between its low and high points, I read about 28 ohms, 29 ohms, 30 ohms at the low point. To about 350 ohms, subtracting the 10 ohm offset that my multimeter reads at direct continuity between probes, it's about 10 ohms. So subtracting that 10 ohms from the low point, so 33 ohms minus 10, that's 20 ohms. (350 ohms minus 10 ohms, that's 340 ohms. So it's supposed to read 20 ohms to 340 ohms across the distance of that trackpad. And I believe there's like a faulty connection either on the swing arm that's supposed to ride on that trackpad, or it could be this leaf spring at the bottom, which is not contacting the chassis because of high resistance or so forth. At this point, because I'm not getting very good results, I'm going to actually remove that mushroom splayed out edge and remove the entire piece, see if I can correct the issue between the leaf spring and the chassis on the bottom of that, and to make sure I get good continuity there, because I believe that's where the problem resides. So what I got here is a Dremel tool, grinding off the tangs there that hold that pivot arm in place from here and there, which I will attempt to do now. Just a word of caution, if your fuel tank has seen fuel and this is still wet with fuel, it would not be advisable to take a Dremel tool to it. Sparks, in fact, might ignite the fuel that's surrounding. I would thoroughly dry it off. Your workspace does not have any flammables around it, because my fuel tank has been dry, bone dry, for years. It doesn't have fuel in it, there's no hazard here, but your situation might be different. So just be cautious about that when creating sparks. So here's the float. Been removed from the chassis by grinding the tangs off the end of that, which retained it to the chassis. And here are the pieces. The contact arm, which I previously polished up, and this leaf spring, which perhaps provides the continuity to the chassis. Perhaps the resistance there is high. You can see some built-up corrosion on the chassis. That could be the issue too. So here we can see the parts after I finished sanding them with 600 grit sandpaper. They look all shiny and new. On both sides of the leaf spring. Just trying to attempt to flip it over here. See the nice reflective surface. Try to sand that up there. You can see a couple large scratches if it focuses, because I was using too heavy a sandpaper, but 600 grit, if you use it, you won't get those large scratches. Hopefully a long-term effect of that is not going to corrode again, but we'll see. So after sanding, we got a nice shiny surface. If the light will reflect, you can see all around that area. So hopefully that does the trick. I'm going to make one more point actually, because it is a point of contact. If you were to sand up the fuel float arm before reinstalling the set screw against it through that brass piece arm, it'll provide an additional point of contact. think that's a good practice when reassembling. So the job of those tangs that we just ground off was to retain it so that it wouldn't pull through and come loose. It won't actually pull through and come loose because you still have the set screw holding it in. But what's going to happen without those tangs to retain it is that it's going to put lateral force down this way, side to side, which is perhaps not desirable. I guess it would be desirable because you'd provide force for that, but just to try and avoid that whole thing, I'm almost thinking taking a 1/8 inch rivet, separating the head of the rivet and pinching it onto the end of that shaft to help retain it against there. So I'll give that a shot and see how that works. Setting the head of the rivet in a plier and just sort of tapping it so that the end of it comes loose. Seeing now if we can get that on the end of there and pinching it so it doesn't come loose off of here. So I'm thinking mixing up a bit of epoxy, setting it inside there just before pushing it on, and crimping it on with some pliers will help it stay. So what I've done with the head of that rivet that I prepared with the epoxy as well is use a 4-inch bench type vise to actually just clamp down on that end of that rivet, not on the flange side, obviously the flange side stays flat, but just clamping down on the cylindrical part that actually travels down the end of it to pinch it onto the end of this float arm. So I've done that. Now releasing it from the bench vise. You can see that's pretty on there now. It's not going to go anywhere. So retaining the float arm to this piece has effectively been accomplished. So I've hooked up the multimeter again, and I've actually measured good resistance, range, and continuous continuity without interruption as I pivot the float arm from high to low, low to high. I did notice the low point and the high point in the resistance range. I was a little offset from our actual measured on the trackpad, from low point being 20 ohms, high point being 350 ohms, as you will recall. So I've just kind of set the error between both the low point and the high point so that it was equal. I've adjusted the travel or the leaf spring so that it's pressing equally and relatively horizontally between the chassis and the arm bushing, and adjusted it so that the travel on the arm from high point to low point travels approximately the entire range of the trackpad. And that rivet is actually holding everything very nicely snug without any play in that end there. Connecting our multimeter leads and having a look at the range on the multimeter. Goes to about 48 ohms, 280 ohms. 48 ohms, 280 ohms. 48 ohms, 280 ohms. And everything in between. There's no loss in continuity or opens in the circuit. It's continuous. Maybe the range that my fuel gauge reads will be out of either, it won't actually fully read full and it'll read more empty than it does full, or vice versa, it'll read more full than it does empty, but at least it'll be a rough indicator of how much fuel is in the tank. I guess as a preventative measure to prevent future corrosion from taking place on that leaf spring, bushing, or travel arm against the trackpad, it might be advisable to spray it down with electrical contact spray or WD-40 before reinstalling in the tank. It'll at least temporarily protect it from corrosion or so forth until you get some fuel in there. Thereafter, hopefully you use good fuel in your motorcycle or fuel tank that has minimal to no water content in it. As long as it's submerged in fuel, no corrosion should take place. I suspect this issue may have resulted as a result of the tank being empty for a number of years, possibly just due to normal wear and tear as well, with the fuel tank running empty from time to time. So I think I'm going to call that fixed.